Okay, now according to relative time, if we have a planet with an observer, A, and a jet passing by, going at a high speed around the planet with observer B inside, and both observers have a clock which was pre-synchronized, and this jet flies all the way around the planet and lands, then the clocks will be examined to show that the time that passes for observer A was a full duration of time, while the duration for observer B is behind slightly. Now, according to relative time, that's because a moving object at a high speed is actually experiencing time slower than a person or an observer that is stationary. Now, one could make the argument that both observers are correct in their predictions based on their own position in the universe. Except that raises another question. If both make the predictions out loud to one another before the experiment is made, then at the end, what happens? Which one admits they were wrong? There can only be one situation happening at the same time. If I am observer A, for example, and B makes the prediction that my clock will be behind his own, then at the end, what will it be? Will I be correct or will he be correct? Even though we're both using the same perfect reasoning based on both relative time and space. We're both basically left to basically see the other one admit his own wrongness. Only one can exist at the same time. There can only be one end to this experiment. Alright, here's the next example of why relative time and relative space cannot exist together in the same universe. Here we have three crafts. I will call them A, B, and C in the deep void of space. They are all spacecraft capable of high speeds. Now, an experiment is being done in which all three crafts possess a clock. And the goal is that during a certain duration of time, there will be an acceleration in which all three crafts are applying forces against each other to propel each other away from one another in space. And during the time at which that acceleration is taking place, the clocks are not counting up time. But after that acceleration is over, and all three crafts are drifting at constant velocities, the clocks then start to count. So, observer A observes both B and C traveling away from him during the acceleration. And after that acceleration is over, and all three crafts are traveling at constant velocities relative to each other, all three pilots make three different predictions. Here are their predictions about the clocks. This is based on relative time. Okay. This is the predictions of pilot B. These are the predictions of pilot A, and these are the predictions of pilot C. Now, since pilot B observes craft A traveling away from him at a certain constant velocity v, he observes craft C traveling away from A at that same velocity. Therefore, relative to him, that would be twice that constant velocity at which A is traveling away from him. You understand? So his prediction about his own clock is that a full duration of time will have passed. His prediction about the clock from pilot A will be that not as much time had passed because his clock will be slower. And his predictions about the clock of pilot C will be whatever that time is slower than his clock times 2, because it's twice the speed, twice the velocity traveling away from him. Now, these are the clocks going from, these are all B's clocks in each prediction, these are all A's clocks in each prediction, and so on. So if we go on to the predictions of pilot A predicts that since B is moving away from him at velocity v, his clock will be slightly behind his own. And his own clock will have had the full duration of time passing. When he predicts what clock C will be, since he is traveling away from him at the same velocity which B is traveling away, he predicts that the time difference between B and C will be the same. Now, pilot C will be basically the same as pilot B's predictions, only in reverse. A full duration of time passing for his own clock. He will predict that clock A will be slightly behind, and clock B's clock will be behind twice as much as clock A. His clock is behind. Now, when they all reconvene after the experiment is done, who is correct in their prediction? Now, again, if we establish that one of these three crafts is indeed stationary, then relative time can work. For example, if we establish that B is stationary, this prediction made by B is true. And all the other crafts will then have to predict according to his being stationary. But relative time does not establish that anything is stationary. And if we surrender relative time, then this situation wouldn't exist to begin with. So relative space operates fine without relative time, and relative time operates fine without relative space. Now, some will try to still say that each pilot is correct in his own right about their own prediction, but I have to ask this question yet again. If A is correct, does he suddenly branch off then into his own separate universe in which he is correct and all the other observers are completely dumbfounded that their own predictions, based on perfect reasoning according to relative time, are incorrect? Will B and C then branch off into different universes based on their own position in relative time and space, in which for B, A, and C are incorrect, and for C, A, and B are incorrect, but he is correct? You can only have one at the same time, unless, of course, you create some kind of paradox, which is somehow allowed. But Einstein's theory of relativity does not answer that question.